Welcome to my channel once again. Today we are going to talk about unit root test, and from the previous video we talk about multiple linear regression using Gretl. Today also we are using Gretl as well. So today what we are going to do is about unit root testing using the Augmented Dickey-Fuller test and then the KPSS unit root test. We will start with the variables one after the other. We are not going to do it for all the variables because this is just a tutorial video and I'm going to show you how it is done. First, I will take GDP, then I'll go to variable and I'll select the augmented, which is the ADF, and it's that we are going to use lag 1, or we can increase it if you want. You can choose the maximum lag you want, but for me, let's stick with lag 1. And also we have the criterion, which is the Akaki information criterion. You can also select the BIC, which is the Bayesian criterion, so information criterion. So you can use that one. For me, I'm going to stick with the AIC. And then the test that we are going to perform under the ADF test, we have 3 different variants, which is the test with constant and trend, and without constant. So you can see here, as I have selected all of them, or the system have selected all of them. And you can also test with this one, but usually it is not used much often. And in research, most people use with constant and trend. But for me, we are going to use these 3 scenarios or 3 variants just to make sure that we are doing something which is a little bit detailed and much practical. After that, we have to select show regression results, and we are going to use level of variable because we are not doing it with the first difference. So first of all, after selecting everything in this order, you just need to click on OK. I have clicked on OK. Now let's go back to the word here. The condition is that unit root is present when the p-value is greater than 5%. That is the null hypothesis. There is no unit root present when the p-value is less than 5%. So let's go back to the output. When you check the output here, the variant without constant shows a p-value of 1, which is the maximum you can get because it ranges from -1 to +1, and usually some people will say that at 1 it shows the maximum. And here you can see that the p-value is 1 and it shows that there is a unit root present. But we need to go to the other options which talks more about in terms of research work using the variant which is with constant and trend, and with constant only. And as you can see from this side, with constant only, you can see the p-value is also 1, which shows that there's a p-value, there is a unit root present. There's a unit present in the variable. And you can see from this place too, with constant and trend, it shows that the p-value is greater than 5%, and it indicates that there's a unit root present in GDP. For instance, looking at my table here, I have a very long table in terms of the length, and you can see from this side that I have this header here, which is the variable, and I have the sample size, I have the ADF test statistics, and I have the p-value, I have the critical value here, I have the ADF test again, which you can see it's at the right side. For my case, this is for at level, and this from this part to here is for at first difference. So if I want to input the output I got from this place, I don't need to transfer everything. I'm just going to get the information I need for my table. So first, as I mentioned, ADF test statistics, you can see from here, you can see that there's a test statistics here. Just copy this one, and I'm going to copy up to this side because I need it after the decimal. There should be only 3 digits. So I'll paste it here, and then the critical value, which is this one, the alpha minus 1. So you got this one. You copy up to, for me, you can, someone will choose to copy everything, but I will just use up to, after the point there should be 3 decimals, so 3 digits. So in this regard, you just need to copy the p-value and then you paste it, and you can see from the year it used, the sample it used, you just copy it and paste it here and input the variable name, which is GDP. So once you input this one, we are done with the variable GDP at level. And for one or two reasons, some people use different method. Some people will choose to use the vector error correction model, and some people will choose to use the ARDM model, which is the autoregressive distributed lag model, which is very advanced. In this situation, I'm just giving you the basic steps we are going to use. So in future or in our in our next episode, we might talk about the vector error correction. So I would like to perform a unit root at first difference on GDP just to show you. So at this point, I'll close this one because I don't need it. You can choose to minimize it, but I will not. I'll close it. So at this point, I'll just go to variable again because GDP has been selected or highlighted already. You go to unit root and select this one. And here it's already showing that we've selected this variant. And look at this point, we are not going to use level of the variable anymore. We are using first difference. So take this one, then you click OK. And as you can see here, it shows that there is unit root present using the variant without constant. Here, there's a unit root presence using the variant with constant, and here there is no unit root present using the variant with constant and trend. So I'll copy these things and paste it. I'll paste it here. This is the ADF test statistics. I'll copy the critical value and paste it as well. Get the p-value and copy it. So I'll also paste this one here. And once this is done, it shows that at levels, GDP has a unit root, and at first difference, there is no unit root. You can see here, like I said, if the p-value is less than 5%, it shows that there is no unit root present. And if the p-value is greater than 5%, it shows that there is a unit root present. So let's do it for other variable, and then we will move to the other unit root tests using the KPSS. So I am going to close this one again. Then I'll move to, let's say, trade openness. So I'll select that one, go to variable, go to unit root, then select the augmented. Then we are using this one because we are testing at level. So you click on this one, you can see that here you can see that there is a unit root present because the p-value is greater than 5%, and we are following the same steps as we did for GDP. So you need to copy this one up to this point. I don't know, like I said, some people will choose to maintain all the numbers they had. So I'll copy this one as well, paste it here, and copy the p-value. So I'll copy this p-value, then paste it here. So I'll copy this one as well, the sample range it used, and paste it here. Then put the name, which is the trade openness. So let's do it at first difference for trade openness as well. As I mentioned, that if some people will be willing to use the vector error correction and then the ARDF model, they would like to perform for first difference as well. So we can close this one and then move to unit root again, augmented. Then here we use first difference. So I'll click on this one. Okay. Now you can see here, it shows that the p-value is even less than 1%. And going down, it shows the same thing here. So this shows that at first difference, trade openness has no unit root, and it shows that it's stationary. So I'm going to copy this that I need for my table. So I'll paste it. Also copy this one and paste it here. Then the p-value, since it's less than 1%, it means that you have to put 4 zeros and then point, then 0 before this one comes. First, let's say, instead of putting this one, I'll just make it 0, 0, because it's less than 1%, and it means that there's no need for me to write all these things. Or some people may choose to copy this one and paste it here without putting 0, 0, because they just want them to know that that is the p-value they had. Because if you want to do it this way, it means that you have to put 1, 0 and then point. That is the 0.5 ending shows that this 0 showing that 0.5. It means that you have to put 0.0000 before these figures. So for me, since it's less than 1%, you just need to put 0.000, which is 3 decimals after the point. So we are done with the ADF. We can move on to the next test, which is using the KPSS. KPSS is the opposite side of the unit root test for ADF. Here, the null hypothesis states that there is no unit root, and then the test statistics must be greater than 10%. And if there is a unit root presence, that will be the alternative hypothesis. It means that this is going to be, let's say, more than 10% or less than 10%. So it is the opposite side of the ADF, because the ADF, the null hypothesis says that there is a unit root presence, but the KPSS says that there is no unit root present. So I'm going to test for that one as well using the same variables. In the subsequent subsequent videos that we will be talking about, or in the next episode that we will talk about, I'll make sure we go into details and then try our hand on the vector error correction so that you get to know how it works. But before we do that as well, we need to do co-integration. So in my next video, I'll talk about co-integration tests. But today's video is much focusing on the unit root test. So I'll close this one. Let's start with GDP again. I'll select GDP. You go to unit root. You can see KPSS here. I'll select that one. I'll leave it to maybe this lag. And you can see here, show regression results. You can as well as include the trend. And we are using at levels. So I'll click on OK. And you can see here that the test statistics is greater than 10%. So we are going to reject the null hypothesis and stick with the alternative, which shows that indeed there is a unit root present. So here, what you need is this one. I'll copy this one. I'll copy this one. That is for at levels. I'll copy this one and paste it here. And also the p-value, it means that you can see here, you can put what you see over there in the box here. That's you. So it's like this 0.01, as you can see here. So the next thing is you put the variable name, which is GDP, and put the sample range, which is from 1991 to 2021. So this is for at level, and then at first difference we need the test statistics and the p-value, which I'm going to test for it. So at this point we need to close this one, and then we go back there again. Variable, you go to KPSS. Here, instead of using this one, level of variable, we are going to use first difference of variable. So this one, you click on OK. And as you can see here, you can see when you're using the at first difference, you can see the test statistics is less than 10%, and it shows that there is no unit root. So here we will accept the null hypothesis because the test statistics is less than 10%. So I'll copy and paste it here, and then the p-value shows that it's also less than this one. So you just have to paste it here as well. I'll do it for trade openness as well. So I'll close this one and move to trade openness, and I'll go with KPSS. Here you can see we are using at level. I'll click on OK, and you can see it's also greater than 10% at this point. So we will copy this one and then paste it, and this is the p-value we got. Please, at this point we are not focusing on the p-value we had here, because the test statistics is the main condition we are supposed to use. So I'm going to paste this one here as well. This is greater than 10%, as I've indicated here, and we will copy the observation it used, which is this one, 1991 to 2021. So I'll copy this one, paste it here, and you can write your trade openness, which is the name, and also we'll close it and do it at first difference. I'll go to this place, select this one, and let's add first difference to it, and you can see here it's also less than 10%. So I'm going to copy this one and paste it, and also the p-value, paste it. So at this point, we've conducted a unit root test using the KPSS and also the Augmented Dickey-Fuller test, which is the ADF, showing that at level the variables have unit root, and then at first difference there is no unit root. But before we end this session, I would like to show you something. At this point, at some point, if you realize we were using the variables at first difference, and if you really want to use at first difference as well, you can also go to add. You can see here, add first difference of selected variable. You can also add log of the selected variable, and you can also add lags, and you can also add squares. You can also add logs. So whatever you seek to do at this point, you can go to add and then add first difference, as we were using first difference. So if you just don't want to worry yourself much, instead of going to select that box, you can also add your first difference. Once you highlight it, you don't need to select that box. You just move straight away by conducting your unit root test. So this is one of the tricks about the unit root test as well. And I believe today's session we've learned something about unit root. And our next episode we will talk about co-integration test, which after the co-integration test we will move on to the vector error correction model. Thank you for your time.